I spent 160 yuan to make an 80,000 mAh power bank. Not only can it charge a phone, but it also works as a 12-volt emergency power source. On the side, there's a cool wheel to check the power level, and it supports fast charging up to 200 watts. It turns out the results are pretty good, supporting quick charge and discharge. I plan to buy 4 new batteries to make a high-efficiency power bank. So these large cylindrical batteries have very low internal resistance. My measurements show each single cell is 1.5 milliohms. This means its discharge and charge capacities are quite strong. So I bought 4 new lithium batteries to assemble a 12-volt, 20-amp battery pack that can carry 0.2 kilowatt hours. It instantly beats the capacity of many power banks out there. After connecting the batteries, I need to solder the wires with this copper plate. The overall internal resistance is 6.5, which is still relatively low. We could even start a car without any problem. We'll continue testing. After connecting the battery strings, we need to add a layer of protection. Otherwise, if used directly, it could damage the batteries easily. So I used a 3D printer to make an outer shell. This way, it protects the battery and looks nicer. Next, I'll design the functional features. First, I plan to add a phone charging module, then a 12-volt power supply. The third feature is for emergency car startups. Next, we'll add the corresponding modules for these functions. This will be a 12-volt series lithium battery protection board that can monitor voltage and current. Then, we'll create a DC module for phone charging using a 12-volt step-down module. So what remains are some interfaces. How to apply this to a shell? I reprinted the shell. It can fit all the components perfectly into this shell. I also designed many ventilation holes to effectively dissipate heat from this voltage step-down module, as it's the biggest heat source. Then, there are some interfaces and switches that you can directly install on the battery for use. Finally, let's take a look at their finished product. Finished product. At the front is a cooling fan and a flywheel motor. So on top there are various interfaces and chargers, and then the switch. I designed this backlit key lock switch. Once turned on, the flywheel motor can show the current charging efficiency. On top there are 2 12-volt interfaces that can output 12 volts externally as power. Here is the XT60 for jump-starting cars in this large capacity situation. If you want fast charging, I also designed 2 DC 5.5 interfaces. It turns up top to 200 watts for fast charging, filling up in about an hour. Next up, let's test its actual capacity. How much is it exactly? Connect a 12-volt outdoor lamp as a load device. Let's set the power to 50 watts. On this cooler, you can see the current voltage and current. We can see how much electricity it can output. So the final discharge result is out. It released a capacity of 20 amps and then 210 watts. Finally, the capacity of this EV lithium iron phosphate battery is quite reliable. In the end, what do you think of this 12-volt power source?